In this course section, student teams have built simulated lift stations, the type of system used in wastewater treatment systems to carry wastewater from communities to the treatment plant. And the way it works is that we have a sump, in this case just a plastic bucket collecting water. In the bottom of that bucket we have a submersible pump, and then we have two liquid level switches, float type switches, in the bucket. The idea being, when enough water accumulates in this bucket to trip both the switches, the pump turns on by a relay circuit. The relay circuit latches and keeps the pump running until the water pumps all the way down to the low level switch. In this particular case, the water is being pumped from the lower bucket to an upper bucket right here through a tube that hangs down to the bottom of the upper bucket, so that when the water level reaches the lower switch and it trips that switch back to its normal position, the relay circuit unlatches, the submersible pump turns off, and then water will siphon back from the upper bucket down to the lower bucket naturally through the same tube that was pumped through. That refills the lower bucket until the water hits the high level switch again, and the cycle repeats. Now, in a real wastewater control system, the liquid in here would not be clean water, of course. It would be wastewater draining in from houses and businesses and such. And when the level reached the high level switch, the submersible pump would turn on and pump the wastewater to the treatment plant. And then when the level pumped down to the low level switch, the submersible pump would stop. It would wait until enough level had accumulated to reach the high level switch again and start its pumping. Also, in a real wastewater lift station, you would typically find more than one submersible pump for redundancy. In this particular case, we just have a single pump to illustrate the concept, and like I said, we're using gravity and the siphon effect to return the water from the upper bucket down back to the lower bucket. You're about to see right here, the switch is going to trip off the lower switch. Take a look at our relay circuit. You can see the relay is energized right now, and there it just turned off because the water level hit the low level mark. Now as it hits the low level mark, we're going to see water siphon back from the upper bucket down back to the lower bucket by gravity. And that water will re-close the low level switch, and then as it builds up higher and higher, it's eventually going to hit the high level switch, close it, and activate the relay latch again. The relay circuit is a simple start-stop contactor style circuit. In this case, the starting and the stopping of it is controlled by the two level switches, level switch high and level switch low. We also have in parallel with level switch high a latching contact for the relay to keep it energized after we've hit the high level mark and the water's pumping down towards the low level mark. In addition to that, we also have a manual start push button, which is located over here at our control panel. So students have wired in their own push button switches. This is the push button switch for the particular team we're looking at. When this push button switch is actuated, it closes the contact and causes the motor to start, even if it hasn't hit the high water level mark yet. So the idea here is we have a remotely controlled or manually actuated lift station control system, but it'll continue to run automatic just by the high and low water level switches. And that's the concept here. It's what we're illustrating. So students have constructed this system in about 2 days worth of time. 2 days meaning 2 3-hour lab sessions. So it didn't take a tremendously long time to complete. Of course, we could have taken more time, made things neater, but the concept here is to illustrate how the relay system works. And then once we get all the teams get set up with their working stations, we're going to have individual students do troubleshooting on these. I will come around as the instructor and I will fault these systems. I'll have the students come around and try to show me how they found the fault using their diagnostic equipment. So they'll be following the schematic diagram here, using their multimeters to measure voltage and tell me exactly where the fault is. So I will play the part of an operator describing what the system is not doing right, but not giving them any hints or clues as to why it's not functioning correctly. The students have to demonstrate that, they have to prove that to me within a 5-minute time span. That's typically how we handle the troubleshooting for all of our lab activities. But this particular one, like I said, is for a relay-controlled lift station. This is a prelude to our learning about programmable logic controllers. Before we learn how PLCs work and how we digitally control on-off systems, I want them to see how traditional relay control systems work, just so they get the contrast.